Ladies and gentlemen, good morning. My name is Dominic, the founder of Fire and Security Association of India. I've been involved in the fire industry for almost 35 years. Again, throughout the career, awareness. When we started our career in way back in 1989, 90, nobody knew what is fire alarm system, why fire alarm system is required in a building, and how do we detect the smoke, the early smoke, the different type of smoke, and how do you identify what kind of extinguishing agent is required for different material like electrical fire. So for us, the people who started the career in 1980s when electronic eras was changing, and there was no internet those days, there's no computer those days, when we started our career, and we were all referring to libraries that, every city, every extension had a library. So everybody used to go to library, access to that, and we used to learn out of that. And for today, younger generation, is such a wonderful platform that we have this Zoom or Team and various software that we have, application we have to conduct programs like this. And I myself been part of this movement called Surakshit Bharat, and we continue the journey. Always the people say there is no end to learn, there is no age bar for learning. Okay, so today's session is all about learning, earning and giving. So giving is something that everyone must practice. I'm sure people who are turned 50 plus must start giving to the society for better nation, a better world. And I'm so happy to have our guest today, Sri S. Appavu, a retired Chief Electrical Inspector with vast knowledge, and he has been our delegate in various things, and wonderful knowledge he has. We thought we should also listen to him, understand what are the changes has been coming in the past couple of years. How do you see electrical as an industry changing? And as usual, our well-known face in this electrical industry, Mr. Gopakumar, who has been selflessly trying to transform, trying to build safety as a big element in electrical industry. So today we will listen to him and understand what are those 10 points that makes the building safe. So this is what we're going to understand today. As we all know, Cape Electric has been the catalyst in bringing many of the knowledge series today, and they've been sponsoring. They have been investing in free knowledge, and I'm thankful to Cape Electrical, who is owned by Mr. Gopakumar, continuously, putting an effort to transform this great nation called India. As you all know, the long journey since 1998 to 2022, from hardware to software today, they have launched a digital platform as a knowledge and process partner to ensure safe operation of low voltage electricity. That's called the full form of SOLVE. Safe operation of low voltage electricity. It's a software, it's an application which you can download, and you can interact, how safe, you can understand how safe your installation is, how safe your electrical equipment is. So is long journey from 1998 to 2022. So today they call leading the market with the right solution. If that is the motto of CAPE, and continually training people and continue to groom young engineer. I want to thank CAPE once again for not only doing business, but at the same time doing the great contribution, bringing the transformation in electrical practices. Ladies and gentlemen, I would like to welcome Sri Appavu, who is a Chief Electrical Inspector retired from Government of Tamil Nadu. He is a certified energy auditor under BEE, conducting seminars organized by BAS, CEA, BEE, IEE, FICCI, and many more. On specially electrical installation, design, safety, earthing and energy conservation. He has undergone training in Japan under the Indo-Japan Dialogue on Energy Conservation for India and training in Germany on calibration of reference electrical energy standards. Coordinated various state government departments and stakeholders for the implementation of energy efficiency measure and policy formulation in the state of Tamil Nadu under the Energy Conservation Act 2001 and inspection of extra high and high voltage installation under CEA regulations 2010. We have such a rich, experienced personality today to bless us and give his opening remarks. Over to you, sir.
Thank you. Am I audible? Am I audible?
Yes, sir. Yes, sir.
Thank you, Mr. Dominic and Mr. Gopal. It's a great pleasure. It's a great opportunity for me that you extended. And salute to you, Gopal, for this untiring efforts in this field. Creating awareness is the most important thing among engineers so that they can be confident on the thing what they are doing. First of all, I should appreciate you both. And coming to the 10 important points to be ensured to avoid electrical hazard and any fire in an installation, it's a very good thing. Always 10 means some inspirational quotes. Either it be a Bible or 10 commandments of Bible or what do you call the Quran, 10 points of Quran, 10 verses of Quran, and 10 verses of Holy Gita, Bhagavad Gita, and 10 verses of Tirukural. So when 10 comes into picture, people always remember for verses, and they will readily keep it into the subconscious mind. I hope Mr. Gopal's explanation in his unique way on such important points will be readily accepted by participants. Once again, I salute to the organizer and very good morning to all the participants. Some of them are all my friends throughout the country. They are participating. I'm happy to see them, interact with them all in this wonderful day. And coming to the point, I will touch upon very generic points because you should not become a repetition what Gopal wished to say. It's a notion. Something what I want to say is some generic points that are applicable for the fire and electrical safety. Generally, we should know the constitutional provisions. The constitutional provision vested with every citizen of India is under Article 21. We are enshrined in the Constitution. It's a right to live. It's a fundamental right. It's a right to live. Also, it derives its life breath from the Article 42 and 43 of the Constitution. It's a state subject. They have to formulate the safety. So safety is a subject of state. So though the Constitution empowers you to be safe, this concerned government will have to afford the provisions. Accordingly, the Electricity Act, besides the trading and other things, safety also have been insisted in Electricity Act 2003, and according to which it has created Central Electricity Authority. Under Section 53, it empowers to prescribe standards for the safety of personnel. And Section 54, wherever the public assembly occurs, it has to ensure safety. So, also there is a stringent provision in the Act itself under Section 146. Whoever violates the provisions, any of the provisions of rules, regulations or act will be imprisoned for 3 months and 1 rupee and rupees 1 lakh fine or both. So such is the constitutional and the regulatory as well as act provides safety to the public. Accordingly, the CEA regulation has also prescribed measures, beautiful measures. That can be, all these standards and measures can be revised or that can be fine-tuned. There is no issue in it. But whenever the latest trend or change in trend occurs, we go on fine-tuning. There is no harm in it. But whether we strictly abide by it before fine-tuning is the main question. The thing is that there's a beautiful and quite useful provisions under CEA regulations. Regulations 5 prescribe the electricity safety officer, it is competent electrical safety officer, and a chartered electrical safety engineer under regulation 5A. Also provides for the periodical inspection, then under regulation 30, and regulation 31 provides for the testing of consumer installations, and again regulation 32 is providing for the testing of generating unit, and regulation 36 is with regard to the provision, specific provision of multi-storage building, and regulation 43 requires a prior approval before commencing supply to any installation. So these are the stringent provisions. But in spite of that, we really, the accidents happening and the hazards happening, fire occurring in our country are quite, it's very pathetic to see the accident every day. Almost as per NCRB, that is National Crime Records Bureau, 2018-19 statistics, more than 12,700 accidents have occurred. Unfortunately, in electrocutions, human as well as animal are equally suffering, becoming victim. And among these accidents, there are 55% of accidents are occurring in LV installations. That is less than 1 kilowatt. That is normal 415 volt installation up to 240 watt installation. Then 43% occur in the installation up to 11 kV. And above 11 kV, only 2% accidents are occurring. This is a scenario. So what we have to see here is the single major cause of accident is earth fall. Whether it be a line conductor snapping of distribution line or accident in a home. So these are all due to, most of the accidents are due to earth fall. So we have to analyze it. In spite of all the provisions, why earth fault are not cleared in the industry or domestic. Actually, we are not safe in homes. That's the important thing that we have to remember. Similarly, in earth faults are not cleared by the OCPD due to poor coordination. Poor coordination is one point, and the earth fault will not be high enough to make the fault clear because of the various systems that we are using in the field. One thing is, in fire triangle, Mr. Dominic is aware, is a master in this subject. Anyhow, I would like to touch upon it. Air, fuel, as well as heat are the three constituents of any fire. We have air, it's unavoidable. We also have fuel load, like whether it be a carpet or wardrobe, screens, or transformer oil, everywhere. The fuel is also there. But we can minimize it. But what we can certainly avoid is the heat out of arc or spark. That can be avoided. Provided we provide confident electrical installation design practices, then we can avoid such hazards in the field.
So I think we are running out of time, sir. We have the very interesting session lining up along with us today. We also have a very important guest today as an attendee. We have Mr. James Kuti, who is also the retired electrical inspector. I would like to acknowledge for attending this. Along with Mr. Appavu from Tamil Nadu, retired electrical. We also have Mr. V. Suresh, who is the president of Focus Forum of Critical Utility Services, former HUDCO chairman, National Building Code vice chairman, and former IGBC chairman. So whatnot. We have wonderful celebrities who are listening to us today, and very keen to know what Mr. Gopakumar is going to talk about, the 10 important points. So I would request Mr. Appavu, Mr. James Kuti, Mr. Suresh to remain with us. Probably after the end of Mr. Gopakumar's session, I would like to bring you on the screen and we can take up a wonderful question which audience are quite keen. So we will also spend more time in listening to others about their queries. So let's make this entire session interactive. We'll exchange ideas and see how we can improve our webinars. So all of you know Mr. Gopakumar, who is the familiar face today in India. He is an electrical engineer, director of KEP Electric. He is also one of the members in the working group of Indian and International Electro-Technical Commission. In short, they call IEC. And the technical coordinator of Lightning Awareness and Research Center, Elias Trivandrum. Having more than 27 years of experience in electrical safety, lightning protection and EMC of electrical installation. You must remember, he has conducted more than 100 site studies on failure in electronic equipment and presented paper for over 1,000 seminars and training programs across the country. He also published the article about safety in various magazines and a book by name The Missing Link on the subject of electrical safety. I welcome Mr. Gopakumar to take this session, and I once again request Mr. Vishware, James Kuti, and Mr. Appavu to remain with us, and we will have you on board after he completes. Over to you, sir.
Thank you very much, Mr. Dominic. With more VIP attendees, the pressure also increases to make the presentation more and more perfect. So, thanks for all the attendees and Mr. Dominic and Appavu sir. Let me start my presentation. So, one moment. I hope the screen is visible now and it is in full screen. Yes.
Yeah, you're very clear, sir. Sound is clear. The screen is bright.
Yeah. Oh, thank you, Mr. Dominic. So, ladies and gentlemen, today we are going to discuss the 10 important subjects of electrical safety in low voltage. Please understand that all our programs or the programs which I am making are based out of, or it is applicable for low voltage application, especially within a building or within an industry. Now today it is the 10 points, 10 important subjects which I feel. See here, some of the subjects which I am going to talk would be more convenient for an electrical engineer to understand, but I am sure more than electrical engineers, there are some engineers from the fire department as well, those who are regularly participating in our program. However, I will try to make it as simple as possible for them to understand. Now, as Mr. Dominic explained, I am a member in the IEC TC64, which is the global committee making electrical safety standards for protection against electric shock and fire. TC81 is the IEC committee for lightning protection. SC37 is for low voltage SPDs. I'm also a member in the electrical committee of National Building Code, then National Electrical Code, and so on. But anyway, that is not important now. So I'm going to discuss about the 10 points which has to be considered during the design, erection, and verification of an electrical installation. A short introduction about the company, which Mr. Dominic already told. Actually, during this COVID, as I said earlier, we have conducted a lot of webinars, and then slowly, daily, about 50 to 60 questions come to me on clarifications, and I'm actually a little bit tired of answering. Then I started thinking of some kind of a software which can support the users, and then now we started as a small software called as Solve, but now the interesting point is we are moving towards a kind of an artificial intelligence. We are building up a lot of database into the software so that people can very well log into it and get the answers. We are at 200. We have 200 people working in the company, and we have 2 manufacturing locations. And the subjects which we are always talking is safety. We repeatedly talk on safety. All of you are aware of this. Now, for an electrical installation, I will just hide my video for some time. For an electrical installation, the protective measures required in an electrical installation are categorized into 4. Electric shock protection, protection against thermal effect, protection against overcurrent, protection against over voltage. So basically, protection against electric shock, this is to ensure that the people and the animals are not getting shock. Basically achieved by 2 protective measures called as basic protection and fault protection. This also can be done by an enhanced protective measure. These are a little bit technical words, but for electrical engineers, sometimes these are useful to understand. So basic protection alone cannot provide you safety. You need basic protection and fault protection. Now, these basic and fault protective measures are selected based on the environment where you need safety. For example, some of the protective measures such as automatic disconnection of supply, double or reinforced insulation, electrical separation of one of the item of a current using equipment, or extra low voltage. Actually, these devices, these safety measures, disconnection, double insulation, electrical separation of one of the equipment, and extra low voltage, these are actually the safety measures which can be implemented in general location. That means where common people are available. Whereas in an industrial environment, sometimes you need much more or much different safety situations. And for those environments where you have people those who are instructed or people those who are skilled. So in that area, the safety measures which can be implemented are sometimes called as non-conducting location, earth-free local equipotential bonding, electrical separation of multiple electrical devices from one power supply. So like that, shock protection it can be achieved by various protective measures. In one building, sometimes you have to implement different protective measures depending upon what kind of application it is, what kind of people are involved, what kind of the devices are involved, and so on. Say, for example, in a hospital, the operation theater is a different environment. In an electronic industry, where manufacturing and movement of a lot of materials are happening, the environment is different. The data center is a different industry. Defense is a different industry. So like that, each and every application require different protective measures. The second one is thermal effect, protection against thermal effect. The thermal effect protection is achieved by avoiding heat accumulation, heat radiation, hot elements, avoiding hot elements in an electrical installation. Then you have to have temperature limits, you have to have seals of cable penetration, and you have to limit the temporary over voltages, you have to limit the lightning surges, and so on. So like that, a combination of protective measures are required for thermal effect. Also, a combination of protective measures are required for overcurrent Overcurrent, say for example, overcurrent, whenever in the standards or technical books, if it is written as an overcurrent, you should think that it is an overload current or a short circuit current. Both are together called as overcurrent. And then the final one is over voltage protection. Over voltage protective measures against temporary over voltage, sustained over voltage, transient over voltage, harmonics, and so on. All these 4 safety measures are mandatory in an electrical installation. And now these 10 points, which I am going to explain, are basically required to achieve these safety measures. The first one, the fundamental one, is called as system earthing. System earthing in the sense, most often the electricity is coming from a source, probably a DG or probably a transformer, to a house or to a low voltage electrical installation. System earthing is the subject which deals with how you are getting the electricity from the transformer or from the source up to a consumer's installation and how you are going to use it safely. System earthings are classified into TN system, TT system, IT system. There are, TN and TT are called as earthed system. IT is called as unearthed system. TN system is further classified into TNC, TNS, TNCS, and a lot of such classifications are there. We were conducting 2 hours session exclusively on system earthing. I'm sure most of you must have already participated in. Now, this subject, it is the first and the fundamental requirement of electrical engineering when it comes to generation, transmission, distribution, and usage of electricity with respect to safety. I would say that every electrical engineer, those who are involved in this field, especially generation, transmission, distribution, and usage, they should be aware of this system earthing. And the distribution companies, they shall apply these safety measures appropriately into their system. As a result, the consumer premise is protected, the animals and other people and animal on the distribution are protected, and so on. Actually, the fundamental safety, as above are told, up to 11 kV supply, 46% or 43% of accidents and deaths are happening at the 11 kV, and probably a large amount in the low voltage electrical distribution. Here, the electricity supply company has got a lot of responsibilities. The safety regulations of the government of India says you should follow a TNS system, means a 5-wire system, or an earthed neutral system, TNCS, 4-wire system. Those are a little bit technical words, but invariably nowadays, most of the electrical distribution companies are supplying TT system. And finally, it is actually a kind of a mess. People don't know how the system, what is the actual system and how it is working. So actually, the whole confusion of electrical safety starts from the fundamental itself. So the first point which every engineer, those who are involved in safety, they should understand what is system earthing, and they should implement the appropriate protective measure applicable for a certain building or a certain application. This is the point number 1. Point number 2, overload. After every accident nowadays, we say the accident is due to overloading of the circuit. The building is designed 25 years back. Then we have added air conditioner, refrigerator, heater, and so on. As a result, the load has increased. Then the fire or the accident happened. Actually, electrical engineers shall not make this claim, because electrical engineer knows that there are protective measures implemented in a certain installation, and the protective devices are supposed to operate before the electrical installation make a serious accident. So we have a lot of protective devices in our network. Nowadays we have MCCB, MCBs and all, but olden days we have fuses. Of course, fuses are also equally effective if they are appropriately selected and installed. Very important. If we put an overrated device, of course, it may not work. If we put an underrated device, then it may trip unnecessarily. So The challenge here is, the protective devices must be rated appropriately, selected appropriately for that particular application, depending upon the size of the conductors, depending upon the disconnection time, and so on. You can see the selection measures in the standard IS 732 in clause number 4.2 and 4.3. There are different measures to select it. I am not going into detail of those, the entire measures. Basically, these protective devices, such as MCBs, MCCBs, are supposed to protect the wiring. It is not supposed to protect an apparatus. It is supposed to protect the wiring from an overload. That means once when the current is more than the designed current, then of course the device is supposed to trip. So instead of calling an accident due to an overload, we should start calling that the accident is due to non-disconnection of a protective device or non-operation of a protective device. We have to change the term a little bit. Then only if we start calling this as a non-operation of a protective device, then only people will start realizing the seriousness of selecting the appropriate device and put it into the circuit. One of the subject which is very important with respect to overload is the selection of wires. In lot of cases, in last 1 year, I was doing continuously lot of safety audits. Nowadays, almost 4 days I am traveling and conducting a lot of safety audits, and in most of the safety audits, the wire selection is really terrible. The MCB, I have a case study. Probably after 2-3 slides, you will be able to understand how it is done. Especially here the issue is one is the sizing of the conductor. Then the second is copper wires used through or pulled through conduits. Class 5 copper is used, which is having a higher resistance. The third point is too much wires are inside a conduit. If the conduit, let us say, for example, 1-inch conduit, probably you can pull 5 sets of wires, but instead of 5, probably 10 sets of wires are there. The number of wires are very much high, and most of the electrical installations, the shock protective measures are absolutely missing. I have a case study which I will explain to you later. Yeah, some of the terms which with respect to overload, the terms for electrical engineer, whenever we say an overcurrent, we should think that overcurrent is related to overload and short circuit. Overcurrent is related to overload and overload current and short circuit current. Similarly, we call as earth leakage. Earth leakage means there is an insulation failure and insulation degradation in the insulation. As a result, a leakage current is flowing through the exposed and extraneous conductive parts. So here, what you should do is you should have a device, RCD, which is having a tripping current of 30 milliampere is necessary to protect against shock. 300 milliampere is required to protect against fire, and a device of lesser than 500 milliampere, if you have it in your electrical installation, you don't need to test the fault loop impedance. So 3 subjects with respect to earth leakage is there. One is to prevent accident because of an earth leakage, you need to have a RCD or RCCB of 30 milliampere for shock protection, up to 300 milliampere for fire protection, up to 500 milliampere if you wanted to avoid a fault loop impedance test. So this is how you are supposed to do overload protection. Similarly, the third one is called as fault. Actually, short circuit is happening between current carrying conductors, between phase conductors or between phase and neutral conductor. But due to an insulation failure between a current carrying conductor and the earth is called as a fault. It is also called as earth fault. Means a live conductor is in contact with an exposed conductive part. That means the impedance between these two, the resistance between the live conductor and the earth means the body of the equipment is quite less. As a result, a person who is touching probably may get an electrocution, may get a shock. So basically, overcurrent, leakage, and fault are 3 distinct safety measures. So we should always keep this in mind and select the appropriate protective measure. Case number 3, disconnection time. Very important. A person through his body during a shock hazard, once when the current starts flowing through the body, up to certain time, probably the person is able to withstand. Up to certain time, the equipment is able to withstand without catching fire. So the disconnection time is very important, especially when it comes to fault. As Mr. Apau told, earth fault is the major reason for most of the accidents. For a fault, you can see here what I have shown is this is a transformer. You have a meter, means your point of commencement of supply, your main distribution where I am moving the cursor. Then you have your final distribution board. For final distribution boards, up to 63 amps socket outlets or up to 32 amps fixed electrical installation, the maximum allowed disconnection time is what is shown here: 0.4 seconds in case of TN system, 0.2 seconds in case of TT system. On the same time, the fixed electrical installation, the main distribution boards, the disconnection time is very simple. The tripping time of your MCB, it can go up to 5 seconds in case of TN system and up to 1 second in case of TT system. But please be sure, please keep in mind that these times are derived in the standard, including protective equipotential bonding. Means all the metallic, I have a slide which I will explain later on. So these timings are applicable if you have implemented protective equipotential bonding. If you have not implemented protective equipotential bonding, then the disconnection times, I would say, it has to be even lesser. So the third point is disconnection time of a circuit during a fault. Very, very important. Number 4, earth fault protection. What is earth fault protection? Now I am showing you a TNS network. Means you have a source, you have OCPD stands for MCB, you have a load. The green is nothing but the body of the equipment, and then you have a protective conductor connected back to the neutral of the source. You can find this kind of pictures in all the IS standards. The IS standard I am showing you is the IS 3043. Which is called as the Code of Practice of Earthing, figure number 38. You can find out how to make the earthing and earth fault protection in a DG. Then you see if there is a earth fault, the system shall be designed in such a way that the fault current is quickly returning back to the source. Once when the fault current is quickly returning back to the source, enough fault current flows and it disconnect the protective device. The protective device will be very efficient. If you have more and more fault current, the protective device will be efficient and the disconnection time will be lesser and lesser. So one of the fourth important point is ensure that the fault loop impedance is lesser than the allowed limit and the device is able to trip it. In the upcoming National Electrical Code, we have included this table which says every MCB, you can see MCBs are of type B, type C, type D, depending upon the type of the MCB and its rating. The maximum allowed fault loop impedances are included in a table. Now, the code of practices such as IS 3043, which is not a new code of practice. IS 3043, the first, the first standard came during, I think, 1965 or so. The standard has written very clearly that the fault loop impedance shall be calculated during the design. Fault loop impedance shall be tested during erection and commissioning. Fault loop impedance shall be checked periodically to ensure safety of disconnection of supply. And the first job of the electrical safety auditor is to check this particular parameter. So means you have to have a meter. Nowadays, very good meters are available. You have to have a meter, you have to connect the meter into the circuit and you put it on the test mode. One of our previous webinar was on the testing of this fault loop impedance. We can also send you the link of those videos, which explains how to make this particular test. Now I am trying to explain you one of my experience recently in Kerala. So this particular installation, they had a 500 kVA transformer. The building consists of offices and shops. It's like a semi office come shopping complex. So the one of the shop owner, since he was known to me, he called me. Okay, I was also on the way. Then I went there just for a look, and I had the meter. I put the meter into his distribution board and I tested it. It was a 63 amps MCB in a sub distribution board. So the building owner has given an MCB DB to this particular shop, which was a 63 amps MCB. Plus, additionally, there was a 10 amps single pole MCB for some of his light fittings. Now, this gentleman has connected an air conditioner in this 63 amps MCB. He took 4 square mm wire and he has connected to the air conditioner. So I tested that particular, the terminals of the outgoing of this particular MCB. The result which I got is R to P, R phase to earth impedance is 6.52, the fault current is 36 amps, and you can see here the average earth fault current in that MCB was about 35 to 36 amps. Whereas this MCB requires 630 amps to trip within the specific time. So the current which is actually the earth fault current which is flowing is not even, you can see here, this is not even 5% of what is necessary. The current is very, very small. As a result, what can happen is if this air conditioner makes a fault, you can be sure that the result is fire or the result is an accident. The result of this particular study, even if he has got a 6 amps MCB, type C MCB, even a 6 amps MCB cannot trip in this situation. So the installation was so bad. The actual load current was 18 amps, and the phase and neutral he has used 6 millimeter square for the phase and neutral, and for earth wire he has used a 2.5 square mm wire. Why I am showing this is, up to 16 amps. The phase and neutral and the earth, you are supposed to use the same dimension, which is also a violation here. Now, this, from my experience in last 1.5 years, I have tested probably, or not me directly, probably some of my engineers, or we have association with a lot of electrical contractors or the people, those who are regularly attending our trainings. We ask them to buy the meters and they are going to their client place and they are doing the testing. And out of this, the results, actually similar result of this shop, it is remaining in hundreds of locations across India. I would say about more than 90 to 92% of our installations, the earth fault protective measures are similar. Means there is no safety at all. It is common in houses, hospitals, and offices. Any insulation failure will result in an accident. Now, in this particular case, the shop owner, he called the building owner. Then we met the owner of this particular shopping complex, but both of them, the owner and the shop owner as well as the building owner, they don't have any idea about electrical engineering. But of course, they are the entrepreneurs. They don't know anything about electrical engineers. They have this building was inaugurated probably just before the COVID. So they had the electrical contractor and there is a gentleman to design the electrical system. Then we started interacting with the electrical contractor. The most interesting point is, I'm so sorry to say that the electrical contractor never heard the name. He doesn't know. The word fault loop impedance itself, he never heard, and he never know that this kind of a test exists. This is the situation. So interestingly, for the first time, this gentleman was hearing the particular name, and I feel that almost 90% of the contractors, it is remaining, the situation is same. And then we get in touch with the designer of that particular building. Interestingly, his situation, he told that, no, this cannot happen in my building because I designed the building based on the IS 3043. And then when we asked, okay, did you heard of fault loop or fault loop impedance? He told, no, yes, I did as per IS 3043, but he never heard the name fault loop impedance. And this name is written in the standard in IS 3043. 66 places this name, its definitions, its application are written. In IS 732, about 62 places fault loop impedance and disconnection times and disconnection methods are explained. But this is unknown to the user. Of course, he is not an electrical engineer, but unknown to the contractor, unknown to the designer. This is the pathetic situation. So the second part, the electricity supply company. Did the electricity supply company knows it? Neither the electricity supply company nor the electrical inspectorate, they have any kind of guideline to tell every owner that you should do this test. This is missing. Please remember that this test has been included in the IS 732 during 1989. Similarly, we were trying to check the PWD manual because somebody told that this is from PWD. Then we tried checking PWD, CPWD manual. Nowhere these measures are included. So basically, our installations are really in danger. The question which I wanted to ask is who is responsible and who will correct this? So basically, we are responsible for all the electrical related accidents. Now, the case number 5. Protective equipotential bonding. What does it mean is, in every building, all the metallic parts except current carrying conductors or except some communication wires, all metallic parts must be interconnected in such a way that there is no shock hazard. There are rules how to connect and where to connect. Primary protection, supplementary protection, protective bonding, protective earthing, different words are there. But basically for a non-engineer to understand, very simple, every metallic part in your building must be electrically interconnected except the phase and neutral conductor to avoid shock. Unfortunately, the system which we checked in a hospital, this interconnection called as supplementary equipotential bonding is necessary in a group 2 medical location. Means in an operation theater, shock hazard is more dangerous because the patient, a lot of metallic items are bypassing the skin, resistances are lesser. You need to have a very, very high safety measure. Supplementary equipotential bonding is necessary. Unfortunately, this system is missing in almost 90% of the cases. During the last 2 years, I have visited at least 30 to 32 hospitals for making audits, and 90% of cases this is missing. Other cases, of course, we are unable to test. In fact, in the particular hospital which I am referring now, this particular hospital, they have carried out electrical safety audit recently, probably about 6-7 months. They carried out, somebody did an electrical safety audit, and the interesting subject is they have a special apparatus. It's I would say, I call this as a black box. They have a special panel, which the supplier told that this is an IoT enabled panel. And this IoT enabled panel, the supplier told that it will offer you every kind of safety. And one of the safety feature which they have told me is this particular device will, the box will send an SMS when there is a fault. That means there is an insulation failure. Immediately the technician will get an SMS. And by the time he get an SMS, he has to go to the panel board and he has to rectify the fault. This is what they think. But this is, it is really a pathetic situation. Before you get an SMS, it can catch fire. Before you get an SMS, people can die. So such kind of, idiotic boxes are used across India. Then for this particular engineer, of course, fault loop impedance was, a little bit unknown. But this engineer or the supervisor, he has worked in Middle East. Then I asked about, have you carried out the RCD test? Because RCD test is quite mandatory in Middle East. Then he told, no, we didn't. Then I asked, okay, have your electrical auditor did the RCD test? No, electrical auditor also didn't do the RCD test. Then my next question is, okay, in that case, what the electrical auditor did? Then he told he recommended a few chemical earthing. So Then my final question was, why don't you buy an RCD tester and keep it? Because this is not an expensive thing. You can buy an RCD tester from the market, probably 15 to 20,000 rupees, and you can do the testing. But then his answer was quite interesting. He was saying, this is costly, my management will not approve. And he thought that these tests are not mandatory in India. That means this test is mandatory in Middle East, but not mandatory in India. This is also a truth of our electrical installation. Now, case number 6. Every leakage of current from an electrical installation will see that through the earth means through the metallic parts of a building, there will be a current flow. Ideally, the current flow through the metallic parts must be zero, but due to leakages, there can be a current flow, and this current flow must be limited. Otherwise, it can create a fire. One of the incident, one top leading company, somebody called me that my battery rack is creating spark. What could be the reason? Then very easily we could find out that it was due to a leakage current. They were using a device called as again a black box. I forget the digital earthing system. Means this particular device says that you don't need to earth your electrical apparatus, and that particular system was creating a hell a lot of leakage current, and this was the reason for the arc. So electrical safety, please understand that you don't have any shortcuts. You have to follow the books, you have to follow the science, and only the scientific way of protective measures must be installed or must be followed. Case number 7. Installation category or over voltage category. Here, you must understand that any failure in the insulation of a conductor or an apparatus will create a problem, or it can create an accident. In our electrical installation, starting from the transformer up to the meter board, you have very strong electrical devices which is having a very big insulation. Then at the fixed part of the installation, you have devices which is having a lesser insulation, and your connected devices are having lesser insulation. So there are installation categories, impulse voltages, and so on. What I wanted to tell you is there is a category of device called category 1. Installation category 1 means a sensitive electronic apparatus. You should check the manufacturer's catalog, and if the device is of category 1, actually we are not supposed to connect it directly into a power supply coming from the electricity supply company. From the transformer, a category 1 device we are not supposed to connect directly, but unfortunately, several cases this subject is overruled, nobody bothered. As a result, finally we end up with fire and accident. Case number 8, current loop. Every electrical wiring shall be made in such a way that the current loop, the circulating or the current has to take the shortest path back to the source. If we take a longer path, it may create problems such as electromagnetic interferences, and it can malfunction your electronics. Also, the same case number 8 is a temporary over voltage, means in case of a fault on a transformer. I'm showing you a transformer here on the left side. There is a fault on the transformer on the HT side. So whenever there is a fault on the HT side of a transformer, equipment in your building can burn. Temporary over voltages up to 5 seconds can come into your building, which can create a shock hazard, which can create a failure of apparatus. And technically speaking, the shock voltage and the fault voltage must be limited to lesser than certain limit. But unfortunately, this is also a subject which is of new, or which is a new subject for most electrical engineers. Surge protective device, case number 8, protection against transient over voltages. Of course, nowadays this is becoming important because of the suppliers. There are companies, those who are supplying these devices. As a result, this protective measure is getting popular in India. But the previous two, which I told, the current loops and temporary over voltages, are again very minimum. The case number 9 is inspection. The IS 732 or the BS 7671, the wiring rule of Britain or the National Electrical Code of America or the NFPA 70, all these standards and the Indian standard IS 732 had included the serial number 1 to 18 inspection points in this standard. This actually globally it is accepted, and globally this has to be carried out. But unfortunately, this is also missing. The last one is, I would say, the testing of an electrical installation. There are 10 testings. Of course, there is one more, which the foreign countries started doing, which is called as PAT, Portable Appliance Test. This 10 tests plus the one, or at least the 10 tests, are made mandatory in the regulations or made mandatory in the standards. But unfortunately, you have to be careful and you should do this particular thing. So the case number 10 is testing of the electrical installation, also the periodic testing. In a periodic testing, you don't need to probably do all the tests, but some of the tests are mandatory. So the 10 points which I wanted to force or which I wanted to see that these are the important points which need to be implemented in electrical installation is number 1, system earthing; number 2, overload protection and selection of protective conductors and devices; number 3, disconnection time. Depending upon the system, you should implement the disconnection time, fault loop impedance and efficiency of automatic disconnection, protective equipotential bonding, PE conductor current, installation category or over voltage category, temporary over voltages and the EMI current loops, inspection and testing. These are the 10 important points which I felt if we do it properly, this can actually reduce the number of electrical accidents very much in an electrical installation. Of course, each of this subject, for example, system earthing, that subject itself require 2 or 3 days to understand. We are already conducting webinars. You can also participate in those webinars, but again, this will be exclusive for electrical engineers because other engineers probably this is a little bit difficult to understand. As I said, each of this subject is important. Now we have made the software solve, but don't think that this is an app which can guide you for an electrical installation. No, this is an app or this is a software which guide you how to make a safe electrical installation, and most probably we are actually trying to make it as an artificial AI software which can guide you for investigations. Whenever there is a failure, through some of the simple questions, the software can guide you or can tell us what exactly has happened. Basically, for safety audits and for guidances, we can use it. So, Solve, we have developed a lot of safety measures, and how we are trying to put is Solve will help people in designing the electrical installation. Training modules will be there. Verification of the drawings will be included. Compliance to the standards are included, and you will get the support during erection. And all these necessary points are included in the Solve, or we are trying to include in the Solve. Probably it will take another few more years to finish the software. Only the initial modules for testing and verification is ready. Why I told years is because building up the data is the database is very difficult. We are analyzing each and every failures, and we are putting the data into the system. So now these are the 10 points which I wanted to tell you, and thank you very much for listening to me. And over to you, Mr. Dominic. I have my email address and number. You can note it down, please.
Thank you, Gopkumar, for enlightening us on the importance of 10 points of electrical safety. Also, you said there is no shortcut to safety. You have to follow the procedures, you have to follow the standards and codes if you want to live safely. I also have with us Mr. James Curry Thomas, who is also the retired electrical inspector from Kerala, and Mr. Suresh Vasudevan, who has reached 58 years of experience, the man who part of the National Building Code changes from the start till today. We are so blessed to have him. Mr. Suresh Vasudevan, he is from Trivandrum. He is based out of Trivandrum. I'm so glad to see all of them. So I also have a request to all the participants, those who wants to have an interactive session, please raise your hand. After I'll take few questions from the question box, and we have eminent panelists today. We have Apavo, we have Suresh, we have James Kuti, and Mr. Gopakumar. So you can raise a question, or probably they will be able to also participate in giving the right answer to you. So you can, there is a icon below, raise hand. If you want to speak to them, you can put it. So I will just two lines of a word from Mr. Suresh and Mr. James Kuti. Over to Suresh, sir, 2 words, 2 minutes.
You got to be on my, I can only speak, it's okay?
No, you can also come on video, sir. You can see,
No, it's okay. I was gonna, well, what a pleasure to hear from Apavo Saab, from the Electrical Inspectorate of Tamil Nadu, with all his brilliant background and international exposure in Japan, and the practices there, comparatively one of the finest electrical inspectorate, I would say, Tamil Nadu. And of course, to be followed by the brilliant presentation from Gopakumar, whom I consider one of the best in the country, to know all about the electrical safety installation, codal provisions in particular. And I was so happy to have this very close association for the National Building Code work, wherein the provisions of the lightning protection and other related aspects, we were pretty bad in that. We brought it in line with the Indian IEC provisions, the latest provisions, against stiff opposition from many in the industry who did not want any of those things to come in over there. And we're very happy it stood the test of the time. And Gopakumar's 10-point issues are very good. I raised a few questions already on the question box. So let me not repeat those questions now, which I leave it to you to raise it. I have 2 rounds of questions to Gopakumar and 1 round to the regulator, that is Engineer Apavo. Maybe you may like to raise it that way. But since you want me 2 minutes, I think it's fantastic. And I'm very happy that as president of Focus, we have a great vertical to deal with safe electrical installation. And electrical installation safety is directly linked to the fire safety aspect. All the fires are due to short circuit happening in electrical installation. And therefore, the umbilical cord between both of them. And I'm very happy that Gopakumar really brought it out. And the best thing I liked was the electrical audit that he said towards the end, and the large number of things regarding the materials that the conductors being used, how faulty practices are being used, etc., etc. I'm very happy to hear that. I'm sure all the participants would have allowed it enormously, that I can see from the way in which they're giving on the chat box, as well as some queries also coming. Gopi, you did a wonderful job. Very happy and proud as not only a member of the BIS for the National Electrical Code and National Building Code, and also with the Focus, a very active participant for all our work. My congratulations to you for a great presentation. I'm so impressed. Very proud of you. Very proud of you.
Thank you so much, sir. I would request the participant to raise your hand. You click on the raise hand if you want to participate in the discussion or you want to interact. So I will take people who are raising the hand. I can see that 4 of them are lined up, but however, I'll just pick up 1 question. So this is for Mr. Gupkar. This is from Narsinga Rao, who's been a participant from all our series and very actively participating. Thank you, sir. Thank you for participating. His question is, what should be the floor and wall resistances, impedances to be maintained in a hospital? Please explain.
Yeah. Actually, there is no limit as such. It should be certain ohms, 50 ohm, 100 ohm, something like. It is not like that. What is necessary is the floor and wall. A person who is working on that area, he shall not get a shock from the floor and the wall. Number 1, if the floor resistance is lesser, chance of getting shock is more. What do? You have to increase the floor resistance. So for that, what we should do is, we should test whether the touch voltage, or we have to test and find out the touch voltage. If the touch voltage is more than 50 volt, then of course you need to have a a floor mat or something like that, so that the resistance is increased. Similarly is the touch voltage. Say, for example, in a hospital, touch voltage inside the operation theater and all, touch voltage lesser than 25 volt. So we have to do this testing, and if the voltage is lesser, we are in danger, and we have to do, or sorry, if the voltage is higher, then we are in danger, and we have to put the appropriate protective measure. There is no resistance, but it is actually related to voltage, shock voltage.
Thank you. Sir, again, a question from our panelist, Mr. Suresh V, is asking, Gopkumar, faults and failures in electric safety. What is it due to substandard electrical material and appliances, or poor quality of installation practices, or lack of skilled, trained, certified people, or electricians, lack of development? So with your experience, what do you think the causes of all this? I'm sure all are the causes, but let me hear from you.
Yes, as you said, all are the causes. For example, in one of the seminar, one of the managing director of a very popular wire supplier, he was commenting that about 90% of the wires sold in the market under my company's brand name are duplicate.
Oh.
So this is the situation.
So what is the mechanism, Suresh sir, to control duplicate of electrical? I'm sure that you'll find in Delhi and every major city, duplicate of brands. Is there any mechanism to check on that?
Of course, yes, actually this mechanism is there. ISI marking is necessary, and nowadays if the manufacturer complains, the police or the authority can go to these shops, and the shops can be closed forever. The rules are there, but the question is who will go to these steps, to ensure that the things are in proper condition. So one of the devil in electrical engineering is the duplicacy of the products.
Don't you have a system called test certificate? Like example, I'm buying a cable of certain quantity. Can't I demand the test certificate of the product?
Yes, of course it is there. ISI marked, and the test certificates are there. But the problem is a duplicate fellow also will give you this. Because a duplicate person is, imagine there is a brand A. The duplicate fellow is making under the name of the brand A, and they give the test certificates of the brand A. So it, more than finding out the test certificate, these purchases shall be made from reliable sources. Very, very reliable sources. That is the only way. So the second question from Suresh sir is unsafe, poor quality installation practices. Of course, this is so far the 10 points which I explained is about the poor quality installation practices. The third is skill of an electrical engineer. This is also an accelerator of the accidents, and lack of depth in supervision. Of course, if we go to the modern buildings, which we always see high-rise buildings which is catching fire, there most of the cases, if we look, especially let me say about Bombay, high-rise buildings, of course they are using quality material. They don't use substandard material because they have the system. Most builders have the system to check the quality of the material. So that part is taken care. Probably a house owner may be buying something which is of substandard quality, and he is installing it into a good electrical installation which is creating fire. So in foreign countries, they do PAT test, portable appliance test. So that means there is a small meter. You have to connect your appliance into that particular meter, and the meter will tell you your appliance is in good condition or not. It makes an insulation resistance test. It makes a heat test, and it gives you a sticker. Actually, for example, in Australia, you can connect only PAT tested device into your electrical installation. If you don't do it, and in case of any accident, then the owner is liable. So such systems are already in practice, but of course, PAT test is not very popular in India, or of course, it is not at all popular in India. But these high-rise buildings, I would say, Most of the cases, it is due to poor installation practices. More than the quality of the material, I would say poor installation practices. So I would say this is the answer, Mr. Dominic.
Okay, I'll just go on to the next question from Asanand Kalwani. He's saying, what is electric insulation coating? Can you suggest any company engaged in this service?
Can you repeat the question? What
is electric insulation coating? Is a 1252 the question is
coating.
Yeah.
Insulation coating. Insulation.
Some chemical coating. You remember? You mentioned a chemical coating. Somebody said.
Insulation means different kind of every current carrying conductor. The wire is having a PVC covering. That is insulation.
Okay, I'll just move on, sir. There's one more similar questions, like a couple of people. What is RCD test?
Yeah.
They want to elaborate on RCD test.
Yeah, RCD test. Earth fault protection. We are using RCDs, means residual current device. In houses, we have 30 milliampere RCD nowadays in most of the incoming DB. Now on the RCD, you can see a test button. So frequently, you are supposed to push this button and to find out whether your RCD mechanical parts are in good condition so that it is able to work, because it's a life-saving equipment. So the test number one is you should push the test button and ensure that it is working. Now, periodically, again, for residential, the recommended practice is once in 2 years. Periodically, you are supposed to do the tripping time and the tripping current of the RCD. So what we should do, there is a meter available. You can Google, you can find out RCD tester. Probably it is costing 15 to 20,000 rupees. This RCD tester, you have to connect it to your RCD, and this RCD tester will exactly tell you at what current and what time the RCD is able to trip. So basically, with a meter, you need to test the RCD, which is mandatory in most of the Middle East countries. Of course, in Europe and America, it is 100%. Over to you, Mr.
I now, if Mr. Suresh Kumar, who was there in the panel, do you have any question to ask? Mr. Suresh Kumar, you are on panel. Are you listening? Can you hear us? Okay. I'll move on to the next question, sir. Vilas is asking how to take care of electrical meter fire in our building. Transformer outlet comes to a bus bar and isolator having fuses. Meter and upstream belongs to Maharashtra electricity and downstream belongs to society. Meter was changed and working fine, showing no problem on downstream side.
Yeah, you see, this is where the system earthing and the method of electricity supply comes into picture, because the meter is the property of the electrical supply company, but the fire is in the building. So fire belongs to the building and the meter belongs to the energy supplier. But of course, what the energy supplier shall do is, energy supplier is supposed to test the line-to-line fault short circuit current, line to neutral short circuit current, and line to earth fault current. And he is supposed to make the appropriate safety measure. Say, for example, if he is supplying with a TNS system, and when there is an insulation failure in the meter, before the meter catches fire, the fuse which is supposed to be before the meter is supposed to disconnect. So if the fuse is installed after the meter, of course, it catches fire. And if it is not disconnecting, again, it catches fire.
Okay, I'll move on to Raju. The question is, still we have to go for plate earthing for neutral earth, or is there any advanced earthing now? Can we use copper rod earthing for neutral?
Actually, this subject, the earthing, transformer neutral, It has nothing to do with the plate or pipe or copper or GI. You have to take a wire which is of sufficient rating and you connect it to a bus bar. The bus bar, which can be closer to your transformer, and that particular connection, you have to find out what kind of system you are using. Say, for example, a TNS system. You have to have a bus bar. Neutral has to be connected to that particular bus bar. Then this bus bar has to be extended to your electrical installation, and all the metallic parts of your building must be connected to this particular bus bar. And that bus bar also can be connected to the functional earthing. It can be an electrode in soil. It can be an electrode. It can be the steel reinforcement of your building. So fundamentally, if we read all these things, a plate or two pipes or two pipe-in pipes or two chemical earthing, all these things are actually not at all necessary. These are actually misinterpretation of these standards. So you should implement the correct system earthing.
Okay. Suresh Netam, are you there? If you're able to listen to me, you can unmute and probably you can ask the question.
Also, Mr. James Kuti.
Sir, are you there, sir? Mr. James Kuti, I sent you a message, but I didn't get a word from you on this whole subject that you are listening. Okay, while they come back, we will take another question. Is Vandan Kumar Loda, 33 kV cable punctured. IV side load was only 300 amps. Then what is the reason for cable puncture?
Probably a higher voltage. Insulation failure is, it can also be due to a higher voltage, which is more than the insulation level of the cable. Mm-hmm. If it is electrical, probably mechanical reasons also can be there.
Sir, there Raju again is asking about 12 years, after 12 years, is there necessity to revamp the earth pit, like replacing chemical earthing and plate earthing?
Actually, for your information, our next seminar, which is planned, I think on webinar, which is planned on 21st of May.
It is based on.
Yeah. Yes, it is on exclusively on this particular subject of chemical earthing. Even the IEC had included or made a standard 62561 part 7, which is earth enhancing material. That means what kind of material you should put into the earth in order to increase or improve your system. So our next webinar is on this particular subject, earth enhancing material, and we will try to cover those questions on that particular day.
I think Riaz Ahmad Qazi is also very eager to know understanding earthing bounding requirement for solar PV. Request to put some light. I think Mr. Gokun already answered. Our next webinar, which is now lined up for 21st of May, invitation will come to you, Riaz. It is dedicated only about earthing chemicals. So please do join us, and your questions will be answered on that day, probably enlightened more in detail by the presentation of Mr. Gopakumar. Ishwara here, I don't know the question clearly, but I'll read out to our panelist here. Is type 2 coordination mandatory for all motors in a residential building?
But motors in a residential building, only few motors are there. Like motors are generally used widely in industry, but in a residential building, except other than pumping water, I don't know why so much motors are there. But of course, for industrial application, type 2 coordination of the switchgear is necessary. Appavu sir, any comments on this? I hope Appavu sir is there.
Yes, sir. Yes, sir. Tell me which subject.
Sir, the question is type 2 coordination. Is it necessary for motors used in a residential house?
Yes, it's quite essential. Type 2 coordination is missing universally. There is no coordination between the sizing of cable, the MCB, which is stripping the circuit, and the load, which is served by these combinations. So we are missing. It's a very simple thing. I don't know why the coordination. You did not have a full-fledged design office for that. You just see the characteristics of MCB and the starting characteristics of the drive and the rating of cable. Then there ends only two equations are there, 1.45 times and the tripping type of MCB. If you have a mixer or grinder, then you will have to go for type C, T-type MCB. If it's a pump motor, B would do. So you just see the characteristic curve defined by the IS or IEC and design accordingly.
Okay, sir, I'll go to Smriti Ranjan. Smriti Ranjan Pradhan is asking brief more about fault loop impedance.
Yeah. So before that, I would like to share the screen and give a small information. So I hope you are able to see the screen. Mr. Dominic, can you see the screen?
Yes.
Yes, sir. Yes, sir.
Yeah.
Yes, sir.
Now I'm just showing the website Solve. See, all our webinars which we are doing, in the website you can see a blog. So here, all our webinars are there. As a blog. Now, let us say, for example, one of our last program, if you click this, you can find out the video and you can find out all information about this particular webinar, including the question answers, because there are a lot of questions and including the question answers are included in the blog. So I would request that you please, I will post the link into the chat box. You can also go through this information. Even if we are unable to answer to you, the information, the answers are there in the blog. Please use this method. So now the question, fault loop impedance. See, as a protective measure in a TN or a TT system, you are having a MCB. The purpose of the MCB is during an overcurrent, such as an overload or a short circuit or an earth fault, your MCB is supposed to trip. Now, in an earth fault, in order to find out whether the MCB is tripping or not within the specific time, sometime multiples of the rated current should flow through the MCB. For example, a type C MCB require 10 times its rated current to disconnect within 0.2 seconds. Means a 63 amps MCB requires 630 amps current to flow through it. Then only it will trip within that particular specific time. Now that disconnection current is related to the impedance of the circuit. You have a faulty circuit and the circuit is having certain impedance. It's a closed loop because only through the closed loop enough fault current flows. And this impedance of this loop has to be measured. And for measuring it, actually, sometimes you don't know the length and the size of each and every conductor. You don't know the size of the transformer. So you have a meter, which is called as a fault loop impedance meter. You put the meter into the circuit, put it on to the test mode, and it gives you the fault loop impedance value, with which you can find out the fault current. And from the fault current, you can determine the disconnection time. The test is called as efficiency of automatic disconnection of the supply. And what we have to do is do the fault loop impedance test and find out the disconnection time. Over to you, Mr. Dominic. I hope it's clear.
Yeah. Suraj Sanven, Suraj is asking why TNS is suitable for data center buildings. Since there are multiple trafo and DG in data center buildings, a lot of neutral pits, that is bracket second for neutral, by code and dedicated network things will be there. This will increase number of pits to 200 pits. Please guide on this. Suraj from Mumbai.
It is actually a misinterpretation. In a building like a data center, these modern buildings, you can have, let us say, for example, 50 transformers and 50 DGs. It doesn't mean that you need 200 earth pit for neutral and 200 earth pit for body. No, that is absolutely wrong. Connecting the neutral and body to separate earth pit itself is the biggest mistake. Please don't do it. You have to connect it to an earthing arrangement. Earthing arrangement means an interconnection of several metallic parts in a building. So first you have to have an equipotential bonding arrangement in your building, and the transformer neutral. Say for example, you have 3 DGs and the DGs are synchronized, and the output of the synchronization, there is a neutral which need to be earthed. Probably that particular neutral you have to connect to the earthing arrangement, which is nothing but a bus bar. Similarly, you have a isolation transformer. Isolation transformer output, if you require an earthed system, that also you have to connect to the nearest bus bar. So if you are connecting it to separate earth electrode, and if you are if hundreds of earth electrodes are there in your system, that is a big mistake. Please don't do it. Nowhere in the regulation or the standards this is written. Standards are and regulations are here misinterpreted. Please don't do it. We can help you to design such system. For example, in one of the data center where we have a 220 kV extra high voltage supply, 220 kV, then 22 kV distribution within different buildings of the data center, and then they have 400 volt and extra low voltage. All these systems are there without any earth electrode in soil. Zero earth electrode in soil. So such systems are already there, and these are already included in the standard. So you are supposed to follow these modern measures, not the earth pit in soil. Over to you, Mr. Dominic.
Okay. The question from Ravichandran Krishnasamy, excellent. Thank you so much. Putting together a fantastic which standard. I'll ask you, which standard apply to the elimination or neutral current due to triplet order, limiting the neutral current at the feeder level rather than installing a K-rated transformer will considerably prevent fire accident, in my opinion. A dangerous situation is when a neutral is disconnected due to high current. I think he's suggesting to one of the questions something probably more from Gopakumar.
Yeah, actually, for the neutral safety of the electrical installation from harmonic currents is done by, in case of a triplet harmonic, the current through the neutral will be high, and once when the current is much more, see the point number one is harmonics will deteriorate the installation because of overheating of the conductors, and it is a power quality issue. And this power quality issue, it becomes a safety issue once when the current through the neutral is higher. And what is written in the rules is to measure the current, and if the current is more than the current carrying capacity of the conductor, you are supposed to disconnect the phase conductor, never the neutral conductor. So measure the neutral conductor current, and if it is more than the limit, you should disconnect the phase conductor. So two safety measures are implemented. One is the neutral size of the neutral is increased, even though it is increased, but this safety measure is mandatory. So this has actually, safety has nothing to do with the K-rated transformer and all. With respect to safety, you should measure neutral current and disconnect the phase conductor. So over to you, Mr. Dominic. You are on mute.
Vidya is raising a question. Are the annual electrical inspection conducted by CAIG, a sample inspection, or expected to be exhaustive inspection of all common electrical installations, especially in high-rise building apartment complexes?
No, not like that. The responsibility of the electrical inspectorate, probably Appavu sir is able to explain more, or if Mr. James Kutty Thomas is there, they are able to answer. In my view, the electrical inspectorate's responsibility is to do the system or test the system which is above the notified voltage, or like DG and other things in the low voltage. So electrical inspectorate is not carrying out any test which is in the low voltage, inside consumer premise. It is the responsibility of the user. Appavu sir, any answer?
Yes, sir. I would like to supplement your point. Actually, Regulation 36 provides inspection of multi-storey buildings which receives supply at voltage less than 11 kV also. So state government have to notify the voltage beyond which electrical inspectors have to inspect. But there's a specific provision in Regulation 36, and based on this, the electrical inspectors are inspecting installations of multi-storey buildings, irrespective of the voltage of supply, whether 415 volt or 11 kV. Normally, in most of the 4 or 5 blocks of multi-story buildings, the utility are providing distribution transformers, and all the buildings are availing LT supply only with separate metering to get the benefit of tariff concession and other things. So those installations are also inspected by the electrical inspectorate only. But as the question actually raised is whether testing everything is conducted by the inspectors. It's really a tough job for everybody. The accountability has to be shared by everybody. You have every right as a owner. You have every right to have your building to get the sanction for the building under local body approval, and to engage a contractor. He should know the regulations, rules, and the electrical inspector is insisting drawing. By the time you should evolve a suitable design, then you get it approved. After the drawing approval, we are coming for inspection. So inspection can't be investigative one. It can only be a random sampling. Wherever we find based on the regular flaws that you make in the installation, we point out and we do it. It's ultimately you are the responsible person to coordinate all these things.
So a very important question is coming from Home Bapa. How to withstand RCCB in existing building installation having UPS and inverter and load on UPS and inverter is supplied with common electricity board neutral instead of separate neutral for UPS load?
Actually, using this common neutral for UPS and the other loads are a violation of the basic electricity safety requirement. A neutral, of course, this has been not included anywhere in a standard so far, but the upcoming National Electrical Code, we have included it in a detailed picture. An inverter should derive, or it has to have its own neutral for the load which is connected to that particular inverter. Of course, this is happening only in India, not in other countries, because here we have the habit of one neutral shared with so many load. In such cases, RCCBs actually won't work. If you put an RCCB at the incoming, then if you have an inverter, most of the time, when there is no power, this inverter may create accidents such as fire from the inverter itself, or shock because of the backfeeding of the inverter. There are cases where the electrician working on the high voltage side of the distribution company got electrocuted because of the backfeeding of the power supply from the inverter. So the simple answer is you cannot share neutral commonly. There is nothing called the common neutral. You have to have a separate line and neutral for each of your source. Apau sir, anything to add?
Yes, I think there are several questions based on UPS. Mr. Gopa, can I forward on document that's available with me on UPS recommendation based on IEEE 1100 and IEEE 446? Because people are getting confused with the neutral connection and so many earth electrodes. There was one question. And in my opinion, we have to avoid the common mode noise. This is essential for the sensitive devices or the servers. Whenever you are going for a sensitive device, like servers or PLCs, it is not tolerable for any shift in voltage, any impression of external voltages, whether it be a circulating current or something. That's why they are providing localized transformer or localized TNS system. The TNS system is a must for the computer installations or IT installations. How it is being configured and carried out is clearly given in my document. I will share it with you. You please read it and study it. It is based on
So we will include it. We can circulate it and we can put it in the blog so that all the users can read it whenever they need.
Yeah, it will be available in the CAPE blog. We will share you the link also. However, you have mail IDs of Gopakumar and mine. You can search separately so that we'll send you the document, and we'll be, putting every webinar, every detail, every presentation on the blog. You can just follow that. Let me go to my question also, the same what Amit Kumar is asking, just for layman understanding. Is there a difference between earthing and grounding?
No. Earthing is used in the eastern part of Atlantic Ocean, and the grounding is the word used in the western part of Atlantic Ocean. So the difference is Atlantic Ocean.
Yeah. Oh.
Yes. So in Americas they use grounding, and Europe and this side we use earthing.
But the word is the same. So there's always grounding. Suresh sir, you want to say something on this?
No, it's fine. I think he has given the right answer. I had two more rounds of questions. One for the regulator, Apavu subs. I wanted him to come in because they are the one to ensure. So one question was for him, and one more for Go.
You can ask Mr. Apavu sir. Is there?
Yes, please move on to that question in the chat box, sir. This question.
Why don't you read the question in the QA box? Number 2.
Yes.
After Gopakumar, question was to Apavu.
I will read out the question to Apavu, Mr. Apavu.
Yeah, better.
As a regulator, do you feel there is a lack of full in-depth awareness of all regulations under IEA by practitioners?
Continue. Would it be desirable to license? You please continue the question. Would it be desirable to? Okay, let me answer.
Would it be desirable to license the practitioner for compliance and capabilities or capacities? Point number 2, is there laxity in electrical inspection and enforcement from electrical inspectorate? Is capacity contains in EIT? Third question, do you have annual and periodical inspection and audit in existing building with full capacity and electrical load? Fourth, last, the exposed live wires in a building and ducts pose a danger. I think Mr. Gopakumar also add to this thing. It's a lengthy 4 questions that he's asked.
Yes, Mr. Suresh, it's a vital. These are the vital questions. These actually require close scrutiny across this country. Your questions are very vital, and as an expert, I know that you know the answer. Anyhow, let me explain to the shortest possible. See, the thing is, electrical inspectors, they can't be an expert. Gopakumar is an expert in standard formulation, and Mr. Suresh Vasudevan is an expert in a specific field of NEC. And I can say that Mr. Dominic is an expert in fire and safety. So we can't expect the electrical inspector to be an expert of each and every field. Of course, they can invite the experts and learn things when specific case arise. They can get in consultation with Gopa or Dominic or Suresh Vasudevan to address a specific issue that powers they have. So whatever the mandatory issues are arising, they will certainly call for. But as far as the electrical inspectorate or inspectorial organization is concerned, it is very skeletal. The thing is, we can't, it's a socio-political issue. I can say that it is a socio-political issue. They can't go on increasing the electrical inspectorial organization strength based on the consumer or strength. It is not possible. It is something like police and public strength or judges and cases strength. The electrical inspectorial organization can gain importance by not on its own alone. It is dependent upon the stakeholders like contractors or the policies, regulators, everybody. So the thing is, electrical inspectors can't do as an individually, they can't do things because the law is already there. It is stringent. The act is stringent. Still, the implementation is poor. Why? There is no single, you can say, there is no single prosecution or single compensation of sizable amount to the accident victim like road accidents. You can see the difference. These are the thing, scenario that actually existing in our country. We have to look into this. Regarding the contractor side, we have to educate them. Awareness creation is one of the ways that we can do, and we can educate. And contractors are mainly interested in doing the things in the civil aspect, mechanical aspect, but in electrical aspect, asset consultation they are doing. In electrical aspects, whether the sizing or design aspects are coming, only the consultants are playing a major role. Contractors are just believing what the consultants or the owner, the consultant engaged by the owner, but whatever the flaws, contractors are not aware. This is the actual scenario going on in the field. Hope, Mr. Suresh,
Thank you, sir. My only suggestion is we have to, the capacities of the electrical inspectorate, does it require to be expanded? With now more number of buildings coming, capability to inspect regular intervals, complex issues of tall buildings, which is brought out. My only thing is, in the electrical inspectorate, do you require more and more teams of latest knowledge, etc., latest technologies, etc.? That's my limited point.
Yes, sir, you are right. Actually, it is not the strength which makes a beautiful implementation. It is a will. I don't say that because CESE, competent electrical safety engineers, have already been provided in the regulation, but it is not yet happening throughout the country for the past at least 6 to 7 years. So there are things which we have to address. We are still crossing the IR 56. We have not yet come to the 2010 regulation fully. So the new regulation, everything has to be taken in letter and spirit. Then only it will happen.
So, sir, actually, I would like to add here, the 2015 Central Electricity Regulation had included Chartered Electrical Safety Engineer. This is not a person from the Electrical Inspectorate. It is an engineer who is qualified by the State Electrical Inspectorate. And this Chartered Electrical Safety Engineer can carry out testing and inspection of voltages up to notified voltage. That means high-rise buildings and industrial buildings, which is having a low voltage installation. The Chartered Electrical Safety Engineer is supposed to do this particular job because the limited manpower of the Electrical Inspectorate may not be able to handle it. Plus, it needs a lot of different kind of meters. It has to have large infrastructure and so on. But the problem is, state governments did not implement it even in 2022. It's almost 7 years. This is the answer in short.
In fact, that is exactly what I had in my mind. Capacity building, capability building, this is what exactly I meant. So keep this Chartered Electrical Safety Engineer as an independent one, which is supporting your extended arm of the Electrical Inspectorate to get the job done. And you will be registering them based on very strict testing and capability assessment, etc. And once you do that, then you will find a very strong force, the Electrical Inspectorate, including lift inspectorate, and of course to deal with the capability for testing all the latest one. But as Gope said, These are areas which requires implemented 7 years over, is a hell of a lot of time. Most of it latest provisions of International Electric Commission's IEC documents available, which is a good reference document for latest practices. These type of things are absolutely must in terms of capabilities within the electrical inspectorate as well. Anyway, I'm glad to hear from Pau. Well, let's see what James Kuti has to say on the same, sir. Kerala.
Yes, totally agree with you, sir, Mr. Suresh. Sir. As you said, and Gopa observed that under Regulation 5A, the Chartered Electrical Safety Engineers have already been introduced in the regulation, but state, as I have told, state have to create lot of CESs, that is electrical safety engineers, so that the LT and ME installations, as per Regulation 30 and 43, the state government have to notify beyond which voltage electrical inspectors have to inspect. Before that voltage, below that voltage, only CESs are eligible to inspect and issue a certificate. So based on the certificate, electricity board or utility company will issue supply. But unfortunately, the chartered electrical safety engineer is not at coming. It is not at certified. I don't think whether any of the electrical inspectorate in our country come out with a list of such CSs.
Yeah, sir.
James Kuti sir are there in these. Are you there, sir? Can you unmute and give your comment? Everybody is quite keen to know from your view on this. So, are you there, sir, James Kuti sir?
Also, Mr. Dominic, actually, this chartered electrical safety engineer, the electrical inspectorate from Maharashtra had already conducted the test and qualified the engineer. We have a gentleman, Mr. Riaz Ahmed Qazi. He is an engineer from working with, I forget the name of his company. Mr. Riaz, you can unmute, and if you wanted to add something or your experience as a chartered electrical safety engineer, you can share on the forum. You can unmute.
Is he there?
Yeah,
I think he's there, but he can unmute, but I think he's probably not listening.
Yeah, that's.
Maharashtra has taken a big lead. I think Gujarat is likely to join also shortly, by the way, on chartered electric safety engineers.
Sir, I have a friend, Ishwar Iyer, who is there as a participant also. He is a veteran.
Yeah, he's from Ishwar Iyer is from Ernakulam and Trivandrum, no?
Yeah, he is from Mumbai now. He is
Mumbai, okay.
He is a highly knowledgeable person on the fire. What he's writing is, it is reported that in Mumbai, Maharashtra, almost 70% fires related to improper wiring and short circuit. And 39% of the installed fire system doesn't work. And in addition to that, Maharashtra Fire Board or CFO suggested joint audit by the fire auditor and electrical inspector must do an audit. But who is the competent authority on this subject? So nobody knows. There is no license for even fire audit. Who is a fire auditor? I do audit on my own capacity, but there's no certification. And Government of India does not issue a certificate that he is a capable, fire auditor. But the question is, everything is nice, but who is the competent authority to certify the auditor?
I think there are two components here. Dominic, as Mr. Iyer has rightly said, there are two components here. One is the electrical audit, which is the safety aspects of electrical installation. As he himself said, it is the deficiency in that which is causing the fire. So fire is caused because of the bad installation of the electrical installation, short circuit, etc., etc. The 10 points have to be taken into account. You should have right team. So that electrical audit is one. But fire audit is a thing which is simultaneously now being practiced now, increasing, where all buildings require regular fire audit at periodic intervals. And the fire auditors have got to be recognized by the concerned state fire and rescue services team there. They will have to really see that they got the right qualification to deal with that, possibly based on the provisions required for submission of the application, which is also there in the Fire Safety Act as well as the NBC. So these are joint area, but somebody to do both the electrical safety audit and fire safety audit together will be fantastic. If you are able to get somebody to deal like that, it will be very good. And there, Prasad Rao is saying that National Safety Council is the fire auditors by qualifying the training given by the. So that one answer is there a fire audit. Electrical audit also, I'm sure, based on the same qualification.
No, Ishwara,
Same qualification as given for the CSE.
Yes, Dominic.
Yeah, Ishwar, what's the view? Now, your question is very valid, but you being from Mumbai, Mara, and you've been interacting with all kind of agency across, and with your 45 years of experience as a fire expert or a fire consultant, what is your view on this?
One important thing, as I said, these two things, the lack of, the 70% fires and 39%, that's the virtual double whammy after so many years, despite having the Form B concept, which is among the few states in the country to have that. Despite having that, we know the flaws in that. Despite that, we seem to be still having this problem of so many fires. So the MFB of CFO has definitely, saying that, look, we need to look at the Maharashtra Fire Safety Act and there should be a joint audit, because if the root cause is not attacked, then no amount of fire protection is going to help. It is going to endanger the lives of fire people. Now, what my submission is, now if you look at the certified electrical safety inspector, there's only one Mr. Doifode or somebody. I just went into their website and there's only one. What a shame. Now, if that is the issue, we can't just keep a finger and then say, oh, look, we don't have the certified inspector. Now we should find out a mechanism wherein at least those who are qualified to basically do the inspection and things like people like Gopakumar, who can possibly accredit and then say, okay, here is a group. We need actually an army of people. We have a problem in fire itself. We don't have the accredited auditors. Now, if you look at it, less than 30 meters, they are appointing auditors. My only question to Mr. Warik was, who is basically like training the trainer? Who is actually ensuring that this auditor is having the right knowledge? Is he well versed in NBC? The IS codes when it comes to the sprinkler system. So likewise, we have a challenge there. But in this, there's virtually a vacuum. So we need to look at how do we have a mechanism wherein we have some group of electrical inspectors, if I may say so, not chartered or certified by this one, at least till in the interim period, we need to have competent electrical safety inspectors who can address, and then also like the Form B, we should also have these people looking into this. Otherwise, the meter room is one of the major problems. And also, of course, the PAT. Otherwise, inspection is done, but at the residential level, there is a problem. So who inspects and ensures like things like PAT? So that's a long way. But then the basic thing needs to be addressed. That is, I don't know how the mechanism would be, but my submission is if people like Gopakumar and others can basically unleash an army of, if I may say so, competent electrical inspectors, those who have the basic knowledge and then groom them, that may be a good idea, because now, of course, then things like IoT enabled safety detection systems are also in the market. Again, as he said, what's happened in the hospital, it's just a black box. Nobody knows.
I think, Ishwar, that software what Mr. Cape, like if you look at behind Mr. Gopakumar made Solve, which is a software. If the people start using that tool, they'll be able to know how well the installation, how well the best practice has been carried out by the building. As you said, the root cause is in the fire, as we are all fire guys. Root cause is poor electrical installation practices and short circuit 80%, even though it is not short, but blindly we say it is due to short circuit. So how do you iron? So that, okay, this kind of knowledge in the beginning I said, it's a high opener. It's a blessing in disguise that virtual webinar is happening. A lot of brainstorming sessions are happening. And again,
Dominic, can I make one suggestion? Can I make a suggestion?
Yes, sir.
What I say is, since this is an important one, the technical issue with this series of seminars, Gop and you are doing is fantastic. It opens everybody's mind on every aspect of the electrical one. But I think now this issue on compliance by the practitioners, builders, electrical consultant, electrical engineer on one side, and enforcement by the electrical inspector. Compliance by the people who do the job and enforcement by the department electrical inspectorate is a larger issue. Nothing to do with the technical aspects of voltage and all that. That, of course, will be there. Why don't you have a program exclusively next time, one and a half hour session only on compliance issue and enforcement issue by the two parties which are involved in the particular thing. And therefore, once you do that, all these aspects will come into sharp focus. We have not been discussing that all these days so far. We took it for granted that there is an enforcing, they will do it. Do take that only as a single theme on the particular thing.
Yes, sir.
Look
Yes,
at
sir.
all the electrical all the state electrical inspectorate will come, lift inspectorate will come, all the electrical consultants will come there, electrical contractors will come there, but they are the one going to do the job. How do you license them, etc. Some issues on fire auditors are already there, which is also confirmed by Prasad Rao, etc. Electrical auditor is also an important component, like the CESC to be done over there. Have a panel of electrical auditors on behalf of the government.
Sir, very well said. What the suggested plan, we already have in our mind that we will be having, safety pay charcha. Safety pay charcha, building safety pay charcha. We will have all the component involved in that. It is going to be there's no.
But the moment you put safety, don't get to the technology issue, which is already brought out in detail. See, then what will happen is discussion is normally on the operational issue. Who will do that particular to ensure all those things which are in NBC or NEC or electricity rules, all the 10 points which Gop has brought out in each session is bringing out those interesting things. And those things are to be done. There's no issue. But how will you ensure it's being done let's be concentrating that particular session only on that.
Yes, sir. Good suggestion, sir. Now we are running out of time. It's 1:02. We are short of so many questions here. I would assure you every questions that is there in our question Q&A box and the chat will be personally attended by Mr. Gopakumar and his team. We will get back to you with all the answers that is required. For conclusion, if Riaz, if is there around, I would allow you to speak for 2 minutes. What's your view on this? And Mr. Gopakumar and expert. So since you are unmuted, I believe that you are on the system. So over to you, sir.
Good afternoon, all. It was an excellent session and appreciating Gopakumar for last 2 years. He is sharing a lot of good knowledge with respect to electrical safety. And as far as the implementation is concerned, as people are saying, we need to have a implementation focus. In Maharashtra, we have a chartered electrical safety engineer exam last year. Only 5 people are passed and only one is showing on electrical inspectorate website as one of the chartered electrical engineer. So our focus should be have more professionals in this area, which help us to mitigate the risk and improve electrical safety. And appreciating Dominic for continuous webinars and continuous focus in this area. It really help we all. Thanks all.
Thank you. That is a nice concluding remarks, more like a word of thanks that by Riaz Ahmad Khazi. Thanks for this.
Mr. Dominic,
yeah.
Mr. Dominic, sorry to interrupt you. We have our Sri Bhavani Prasad.
Bhavani Prasad, I think he is left.
My God. We should have greeted him much earlier. I did not know Saab has joined.
No, he is left. I think we have was short our time on this. It's 1:04. I just saw he left. Maybe time for lunch for everyone. Everybody must be hungry. I thank you so much, ladies and gentlemen, for we had almost 470 registration and 200, which is a good turnout for today's session. As Mr. Gopakumar indicated, our next session will be on earthing. Okay, and we will personally contact you each one to join for the program. And again, as there are so many, if you look at it, there is no end to our webinar series. As we conduct, there are new ideas, new thoughts comes. It's not just a business, it's all about giving back to society from what we learn on each every day. So, so kind of you for joining us. We will send you the recording. We will send you those who want certificate of attendance. You can send the request to my mail ID, which is shared by my colleague Lakshmi, who was patiently listening throughout this session. She is posting the comments there. You can write to me. You can write to me for certificate, and Gopakumar will assist you to answer all your questions. And I look forward to see you again. And please share it to bring in all your professional friends to this such forum. And I'm sure end of the day, we can form a group, intelligent group on electrical safety. And, we can change the way we practice in electrical practicing in building. Thank you so much. God bless you. Safe weekend and a wonderful time with your family. Thank you so much. Bye-bye.